welcome to a ramble, a nostalgic ramble, with me, a lover of mathematics and obsessor, a person who is obsessed with past exam papers. So today we are busy with the department's paper 1 from November 2022, looking at question 5. Let's go. The graphs of g of x is equal to 2x plus 1 and the inverse of g are shown in the diagram below. D and B are x and y intercepts are respectively of g. Okay, wait. D and B are the x and y intercepts of g. Okay, cool, got it. C is the x-intercept of the inverse. Okay. The graphs of g and the inverse intersect at A. Cool. First question. Write down the y-coordinate of B. Okay, we've been given the equation of G. Sorry, just got lost a little bit, but I'm back. Right, so just doing some quick work that I should have done initially. Okay, anyway, so first question asks us to write down the y-coordinate of B. B is the y-intercept of G, which is given in the equation of the straight line. So the y-coordinate of B is 6. In other words, the coordinates of B are 0, 6. Right, next question. Determine the equation of the inverse of G in the form G negative 1. I don't want to say to the negative 1. I mean, that just sounds weird. I don't know. X is equal to mx plus n. Okay, cool. So we know that to find so g of x is this. To find the inverse of g, we just swap the x and the y around, and then we make y the subject of the equation. So I'm going to say x minus 6 is equal to 2y, and then divide through by 2. And then we can just split the fractions. So that'll be x over 2 minus 6 over 2. And to write that even more nicely, that's just a half x minus 3 is equal to y. And it's not even that we're just making it look nice. We're following instructions. We're told that we have to write it as m times x plus some number, right? So yeah, so we have to rewrite this as a product of some number and x. So yeah, did I always not have a y there? Anyway, so our final answer then is that g inverse of g is equal to a half x minus 3. Right. And you can even test this, right? Because remember, what is an inverse? The inverse function is something that reverses what the original function did. So our original function takes a number, doubles it, and then adds 6. So our reverse function would be something that takes a number, subtracts 6, and then halves whatever the result is, right? Which is effectively a half x minus 3. We already saw that down here, right? So you can kind of do that test logically, or you can test it with a number, right? So if you input, let's say we input 10 over here, so 2 times 10 is 20 plus 6 is 26. If we then take 26 and put it in here, we should get back to 10. So half of 26 is 13, minus 3 is indeed 10. So we kind of have a bit of confidence that we have, worked out our inverse correctly. Cool, next question. Determine the coordinates of A. This is where the two lines intersect. So we're just going to equate g of x with g, the inverse of g, right? that will give us the x value that gives us the same y value in both functions. So that is 2x plus 6 is equal to a half x minus 3. Get my x's to one side, get my constants on the other. So that ends up being 3 over 2x is equal to negative 9. And then that ends up being negative 6. Right, if I divide both sides by 3 over 2. So that gives me the x coordinate. To get the y coordinate, I can put it into either. And because the inverse is closer, I'm just going to use that. Closer as in closer to me. So that is a half times negative 6 minus 3, which works out to be negative 3 minus 3, which is negative 6. So A is negative 6, negative 6. And let's just see if it works if I put it into G. 2 times negative 6 is negative 12, plus 6 does in fact give me negative 6. So that is looking good. And then the last, is this the last question? No, there's another question after this. Second last question says, calculate the length of AB. Okay, so we have the coordinates of A, we have the coordinates of B, so we can just use the distance formula. Okay, so the distance AB will be the square root of, so I'm just going to note to myself here that A is minus 6 minus 6, B is 0 and 6. Okay, so we're going to minus the x coordinates. No, those are the y coordinates. Oh golly, what am I saying? Those are the x coordinates. Oh my goodness, what am I saying? Okay, minus the x coordinates and then minus the y coordinates. Right, so just to highlight what is what here. This, oh goodness. So this is the x coordinate number 1. Whoa, that is very overpowering. X coordinate number 2, and then y coordinate number 1, and then y coordinate number 2. Right, and that works out to be 36 plus 144 is 118, so that's the square root of 118. And let's just practice working with surds. So what's the biggest square number I can think of that goes into 180 is 36, and the square root of 36 is 6, so we're just left with root 5. So that is the length of AB. Good point for me to just stop and double check my answers. And so far we are looking good. Okay, cool. Right, now for the last question. The last question asks us to calculate the area of triangle ABC. So triangle ABC. Right, so okay, what do we know? We know that this is y is equal to 2x plus 6, and we know that this is y is equal to a half x minus 3. Okay, and we also know that the length of AB is 6 root 5 units. Okay, by any chance are these perpendicular? That would be great if they were. So I'm just going to quickly see if I can figure out the coordinates of C in order for me to find the gradient of BC. So nothing I'm doing is on the record just yet. This is me just fidgeting. So C is the x-intercept of the inverse of G. So I'm just going to make this equal 0. So a half x is equal to 3. So that x must be 6. So C would be 6 and 0. And the gradient of BC would be 0 minus 6. No, what am I doing? So B is 0, 6. This is 6, 0. Okay, yeah, cool. So the y-coordinate of C minus the y-coordinate of B, the x-coordinate of C minus the y-coordinate of B, minus the x-coordinate of B, oh my goodness. So that will be minus 6 over 6, which is minus 1. The gradient of this guy is 2. So minus 1 times 2 does not give me minus 1. So they are not perpendicular, which is absolutely sad. These two are definitely not perpendicular either. 2 times a half is positive 1, not negative 1. And then lastly, are these two perpendicular despite what the diagram suggests? No, they are not. What did I just work out? Yes, no, they're not, because a half, the gradient of this guy, times negative 1 is negative a half, not negative 1. So none of these lines are perpendicular, which means I'm going to need to find the perpendicular height. Well, okay, there's a couple of things we could do here. There could be the potential to use the area rule, so paper 2 stuff. But again, these things are never isolated to either just paper 1 or paper 2. You can use the tools from either world. So I'm thinking that I have the length of this side, right? I can work out the length of this side. And then if I can figure out what this angle is, I could use the area rule. So that's one line of thought that I've got going. Okay, just repositioning. Feels weird. So we could use area rule. Alternatively, I could drop a perpendicular from here to here. I know the gradient of this line, so I would be able to find the gradient of this line. I know that this point lies on that line, so I'd be able to find the equation of this line. I can find the equation of this line and therefore find that point. Why do I need that point? Oh, so that I can find the length of this perpendicular height, use this over here. So that sounds like a lot, but that's an approach. Let's see if we can use the side we already have. We have this potentially as a base. I could find the perpendicular height from here, from C. Right, so I could figure out pretty much same method. Find the gradient of this line using the fact that they are perpendicular. So the gradient of this line would be negative a half. And then I could use this point, 6, 0, to figure out the equation of this line, get the point of intersection of that and this, which will give me that point over here, which will allow me to work out the length of this height, and then I can say half base times height. Yeah, I think that's what I'm going to do. But for fun, I'll also try and see if I can use the area rule, also because I feel like the angle of inclination is such an underutilized tool in my life, so I want to challenge myself to use that. Okay, so let's go over that again step by step. So the first thing we want to do, I kind of whizzed past that very quickly, so I'm just going to redo all of this. So first of all, I'm going to determine what c is. So to do that, we're going to say where is the inverse of g? In other words, a half of x minus 3, where is that equal to 0? So we add 3 on both sides, and then we divide by a half on both sides, or you can say, well, a half times 6 will give me 3, right? So therefore, the coordinates of C are 6, 0. Okay, then step 2 is to figure out the equation of BC. Okay, so we want to find equation of BC. In order to do that, we're going to find the gradient. So we know that the gradient will be, no, we're not finding the equation of BC. Oh my goodness, what am I saying? Okay, right. So we're going to do a construction, right? So we're going to say, let the point D, do we have a D? We do have a D. Okay, let the point P be, let P be a point on AB such that CP is perpendicular to AB. Okay, so that point over there somewhere is P, right? So CP is perpendicular to AB. Okay, cool. Right, so then what we know is the gradient of CP will be the negated reciprocal of 2, right? The gradient of AB is 2, so this will be negative a half, so that when I times them together, I get negative 1 because they are perpendicular. Right, and so now I can find the equation of CP. Okay, the equation of CP will be y is equal to minus a half x plus some unknown c. And then to find that c, we will sub in the point c, right? So we know that when x is equal to 6, our function gives us 0 as an output. So that is negative 3 plus c is equal to 0, and that is c is equal to 3, right? So in conclusion, the equation of CP is equal to negative a half x, oh no, what am I saying? Oh dear, okay, plus 3. Y is equal to that, right? So now we have the equation of the perpendicular height. Okay, so what we further want to find is what exactly P is, right? So that we can then find the length of CP, and then we can say half base times height. Okay, so to find what P is, we need to find the intersection between this line and this line. So, different color. To find P, which is our step 3, we are going to solve for minus a half x plus 3 equal to 2x plus 6, right? Right. So all my x's on one side, I'll put them on this side. So that'll be 2x plus a half x, which is 5 over 2x. Then my constants on the left, 3 minus 6 is minus 3. Divide both sides by 5 over 2. So that'll give me negative 6 over 5. Yes? Yes. So that is the x coordinate. The y coordinate of P will then be 2 times negative 2 over 5 plus 6, which is 6 minus 4/5. I think that is 26 over 5. 6 is equal to 30 over 5. 30 minus 4 is 26. Right. So therefore, P is negative 6 over 5 as my x and 26 over 5 as my y. Sanity check, let's put it in here, the x in here. So minus a half times minus 6 over 5 is positive 3 over 5 plus 3. What am I doing? Right, okay, so minus a half times minus 6 over 5. So that is positive 3 over 5 plus 3, so that is 3 and 3/5. 3 is 15 over 5 plus 3 over 5 is 18 over 5. Those do not give me the same thing. Oh my goodness. What has gone wrong? 2x. Maybe something's gone wrong here. Okay, 2x plus a half x is 5 over 2x. 3 minus 6 is minus 3. Minus 3 divided by 5 over 2 minus 3 times 2 over 5 is minus 6 over 5. So if I put the minus 2 over 5 into here, we get 2 times minus 2 over 5, which is minus 4 over 5 plus 6. 6 minus 4 over 5 is 5 and a 5th. But if I put, oh, what am I doing? Oh, golly. Oh, I've subbed in the wrong thing. Hey, this is meant to be minus 6 over 5, not 2 over 5. Good thing to double check yourself or to just use your calculator. Anyway, minus 12 over 5 plus 6. So that does in fact give me 18 over 5. Perfect. Okay, right. So now I know what P is. So I can now work out the length of CP. So this is part 4 of the plan. Okay, so we know that C has the coordinate 6, 0, and P has the coordinate negative 6 over 5, 18 over 5. Right, so CP will be 6 minus 6 over 5 squared plus 0 minus 18 over 5 squared. Okay, that is definitely going to the calculator. And that is definitely getting shrunken. Okay, right, calculator, come through, do your thing. So that is 6 plus 6 over 5. Okay, oopsie, that is outside our surd. Right, and this one is minus 18 over 5. Oh, squared. So that is, I'll just keep it in surd form. 18 root 5 over 5. Okay, so that is the length of CP. So now we can finally work out what the area of triangle ABC is by saying it is half times base. In this case, our base is AB, whose length we've worked out to be 6 root 5 in the previous question, times CP, whose length we have just worked out. So half times, oh, I forgot what I just said. I think it was AB, right? Half times AB times the perpendicular height CP. So that is half times 6 root 5 times 18 over root 5 over 5. And I think that gives us root 5 times root 5 is 5 times 18 is 90. 90 times 6 is 540. And at the bottom we just have 2 times 5, which is 10. So that gives us 54 square units. Okay, so just as an additional challenge, I'm going to try and see if I can use the sine rule to figure out this area. Let's see, let's have some fun. It's a fun. Okay, so I'm not going to do this one as diligently as, as my previous method. But yeah, okay. What I did really want to do was to split this up, or actually just crop this so that I could make this as big as possible so that I can scribble with ultimate freedom. Okay, let's see what's possible. Okay, so let me just start by writing out what we know. We know that this is y is equal to 2x plus 6, and this is y is equal to a half x minus 3. Okay, so, and we want to work out the area of this triangle. Right, so in order to do that, it would be fantastic if I could find this angle. Right, so let's see what's possible. Using this gradient, using this gradient, I would be able to find this angle, right? This angle of inclination. And using this gradient, I would be able to find this angle of inclination. And then what then? I could find the gradient of this line, right? And that would give me this angle of inclination, which in conjunction with this one could then give me this angle, because exterior angle of this triangle, right? So let's highlight that for ourselves. So we could potentially get this guy, and then and I mean, by knowing these two, that means I know what this one is. So let me do that in a different color. So, oh no. So I would know what this one is, and this angle is an exterior angle to this triangle, right? So it would be the sum of this guy and that guy. Another color. So I would be able to get this guy. And so that's great. Right, that is great. Alternatively, actually, we don't even need to go that far, right? Because if I have this angle, I have this length, I can work out this length, so I can use the sine rule, the area rule, sorry, with this side, and this angle. So I don't even need that guy. I don't need that guy. I just need, so really what it comes down to is, okay, getting this this angle, which I can get from here, getting this angle, so I would need to find this equation, which would then help me get this angle, and then I would have this angle. Oh no, I don't even care about this angle. How did I say I was going to get this one? So I said I would get this one because, oh, what was my train of thought to get this one? Oh no, I've forgotten. Oh, I did need this one, sorry. Okay, so I did need I needed this one so that I could say this triangle, the exterior angle is this guy, so this plus this must be equal to this. Okay, so let's number this for ourselves because we are losing track. Right, so this is the first thing I need to find. This is the second thing I need to find. Then this is the third thing I need to find, and I don't need this one anymore. And then this is the fourth thing I need to find. Right, angle-wise. Okay, cool. So let's write that out. So angle of inclination. Yeah, okay, let's actually write this out better. I know I said I wasn't going to do a perfectionist job of it, but who am I? Who am I? So we're going to say let alpha be the angle of inclination of the inverse of g, right? So then we know that the tan of alpha is equal to the gradient of that graph, which is a half. So therefore a half is equal to the inverse of tan. No man, what am I saying? Alpha is equal to the inverse of tan of a half. And if we shove that into, no, inverse of tan of a half is, so that looks like something I should store. Okay, so so that is 26,56 blah 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 degrees. Okay, cool. Next up, I want to find this angle over here, which is the angle of inclination for this line, G. So again, let beta be the angle of inclination of G. Then we know that tan of beta is equal to the gradient of G, which is 2. So beta is the inverse of tan of 2. And our calculators again come to the rescue. So that will be tan, no, shift tan of 2. So that is 63,43 wara degrees. Store that. Okay, right. So now we know our second angle. Okay, cool. Then we want to find this angle of inclination, which means we need to find the equation of this line, or not even the equation, but at least the gradient of this line, which means we need C, right? We already know that B is 6, 0, 6, sorry, because it's the y-intercept of this guy. So we just need to find the x-intercept of this line, which we already did, so I'm not going to repeat that working, but we found that it was 6, 0, right? So if you were going about this question using angles of inclination, you would have to show your workings to find that coordinate. So yeah, so now we say the gradient of BC is equal to 0 minus 6 divided by 6 minus 0. Well, we worked it out. Anyway, we found it to be negative 1. And so, what's the next letter? I don't know. I'm just going to say theta. Let theta be the angle of inclination of BC, right? So then we know that theta will be equal to 180 degrees minus the inverse of tan of 1, positive 1, right? So this is giving us our ref angle, and then we know that it's 180 minus that because the tan value is negative, meaning we're dealing with a second quadrant angle, right? So that is 180 degrees minus 45 degrees, that is 135 degrees, right? Whoa. So what do we now have? We have this is 135 degrees, that is theta. We have this is alpha is 26 comma something degrees, right? And then we have this is beta, it is 63 comma whatever degrees. Okay, so then we can now find this guy over here. So angle ABC, right? So angle ABC will be equal to theta minus beta, right? So it will be equal to theta minus beta because exterior angle of triangle, which triangle are we looking at? Triangle DBC. Okay, triangle DBC, and that is 135 degrees minus 63 comma 43 blah 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 blah, and what does that work out to? So that is 135 minus recall our beta value, and that gives us 71,56 So I'm going to store that one in D. Okay, right, so now we have the angle. We didn't even need this one. Okay, this one was not necessary, as I just erased that. Because we wasted my alpha. Okay, I'm going to erase that too. You can see how rusty I am with angle of inclination. Clearly, I just need to invent excuses to use it. Okay, so I am now going to quickly work out the length of BC. So BC is equal to 0 minus 6 squared plus 6 minus 0 squared. Oh, look at me desperately trying to squeeze that in. Okay, try harder. 0 minus 6 squared plus 6 minus 0 squared. So I think that just ends up being 36 plus 36. So that is 6 root 2 units. Okay, so I'm just going to, we can keep it that there. That's fine. Right, so now we have AB is 6 root 5, BC is 6 root 2, and this angle over here is 71 comma something. So we can use our sine rule. Area rule. Why do I keep... Oh my gosh. Right. What am I even saying anymore? So the area of triangle ABC will be half of AB times BC times sine of angle ABC. So that would be a half times 6 root 5 times, I just got to commit to our symbols, Are we doing brackets? Are we doing timeses? What are we doing? BC was 6 root 2, and then here we have sine of 71,56. Ooh. And let's see what Mr. Calculator has to say about that. 6 root 5 times 6 root 2, and then the grand finale times... Why does this feel like it's not going to give me the answer I want, guys? Hope and pray, hope and pray. I think the answer was inside D. Yeah, this is awkward. What is inside D? Oops. What's going on? Alpha D has my, the angle. So 0.5 times 6 root 5 times 6 root 2 times sine of D. Yay! Oh, that was looking so weird for 2 seconds there. So that does, okay, that doesn't need a new page. So that does also then give us 54 square units. Okay, so we've had 2 different approaches to the same question give us the same answer, so I'm fairly confident. Here's the memo. Don't let me down. The memo is in agreement. And they have like 3 different ways of doing this, which is so cool. Let's see what their different approaches are. So this is going to be just awkward silence for 2 seconds as I wrap my head around their approach. Okay, so their first answer is quite cool, right? Because they use the fact that G and inverse of G are inverses of each other. So B, the y-intercept here, maps over to the x-intercept over here. So that was a quick way to know that the coordinates of C are 0, 6, 0, because the coordinates of B are 6, 0, 6. Oh my gosh, 0, 6 over here, and then with C they get swapped around. And so the length of AB is also the length of AC. And if we join these guys and then drop a perpendicular here, that is going to split the triangle into 2 congruent triangles. Reason being they have the same hypotenuse, a common side being that perpendicular that we drop, and the 90-degree angle. So that would be RHS. And as a result, this probably makes more sense if I draw it. Ooh. So as a result, if I find the area of this guy, then I found the area of that guy. So then they just, what did they do from there? Oh, so they worked out the length of this using Pythagoras. First they found out what the length of this whole thing is, and then they used the fact that the triangles are congruent to say, well, okay, then half of that length is this, and then they use Pythag to find this height, and then they do half base times height. So that's a pretty neat and quick way to go about it. Let's see what the second approach is. So the second approach is they used angles of inclination, but they used different lines to what I did. So let me see. So they found BDC using, the fact that this gradient is true. Then they found DCA because you can find this angle, right? And then it's vertically opposite. So now they've got that one and this one. Oh, okay, cool. So then they get that one, which is the one I wanted, right? So then they get that one. And then again, using the fact that AB is the same length as AC, you now have that times sine of this angle. So very, very cool. Then the last approach they have is they find the area of triangle BDC. Because we know that this line and this line are perpendicular. We know that. Oh no, okay, we don't. So they find the area of this triangle using the fact that the y-axis and the x-axis are perpendicular. So we know that that is 6 units long, and then they just had to find the coordinates of D. Yeah, we didn't find those yet. We found they found the coordinates of D and worked out this length. So then they get that triangle, right? And then to find the area of this triangle, they have the length of this base. They find this perpendicular height because we know the coordinates of A. So then we know that this is 6 units long. So then half of that times that height gives them the area of this triangle, and then you add them up and you have your answer. So those are all such cool approaches. I love questions like this. It's just, you are free to eat this elephant in whatsoever way you wish. Anyway, enough of me being gagged. Right. See you another time for another video.